Okay, stats, let's do a test review. I took some of the questions you guys asked for, and we're going to try to do them all in maybe 4 videos, 1 for every chapter. No one really asked anything about chapter 9, but I feel like specific, but I still feel like I'll do a question from chapter 9 anyway. So some basics. Chapter 7 will feel relatively basic compared to previous stuff. Find the z-score such that the area to the right is 0.483. So we draw a picture here. Remember, the z-score in your table always tells you the area to the left. So if the area to the right is 0.483, the area to the left, since it always adds to 1, is 1 minus 0.483, which is 0.517. So you go to your z-table and you try to find where you see a 0.517. So I'm looking at my z-table now. Where's my z-table 0.517? It is 0.517. It doesn't look like it hits exactly 0.517, but it does hit 0.5160, which is the closest. So it's approximately at a z-score of 0.04. Now find the z-scores that separate the middle 92% from the tails. Now remember, this is symmetric. So that was, first one was 5, this is 7. If 92% is in the middle, that means the other 8% is split on the outsides, which means there's 0.04 here and 0.04 here. So to find this score, I need 0.92 and 0.04 below it, so I'm really looking for 0.96 in the z-table. So when I look for 0.96 in the z-table, it looks like it's at, the closest is 1.75. Now, these are always, when you're separating the middle, it's always should be exactly the same on the right and left, only one's positive and one's negative. So this one will be negative 1.75. So those are the two z-scores that cut off the outer 4%. So anything between negative and positive 1.75 will be inside the middle 92%. Now let's do one word problem. A tire manufacturer sells tires with a lifetime that approximately follows the normal distribution. The mean is 70,000 and the standard deviation is 4,400. What proportion lasts at least 75,000 miles? So this is where I need to use my z-score formula. So z-score is equal to x minus mu over sigma. So that's r score minus the average divided by the standard deviation. So z is, in this case, 75,000 minus 70,000 over 4,400, which is just 5,000 over 4,400. When you divide those two, you get, let's see, 1 it looks like 1.4. Now, it wants at least 75,000 miles, so it wants the area to the right of 1.14. So here's 1.14. It wants all the things that last longer than that. So I go to my z-table and find 1.14 on the outsides. 1.14. It gives me 0.8729. But that's the area to the left, so I need to do 1 minus 0.8729, which is 0.1271. What proportion lasts 60,000 miles or less? Same thing. X minus mu over sigma. Only now it's 60,000 minus 70,000 over 4,400, which is actually negative 10,000 over 4,400. When you put that into the calculator, you get, looks like negative 2.27. So again, you go to your z-table and find the negative 2.27 on the outside. Looks like not very often. It looks like 0.0116. So the probability that your z-score is less than negative 2.27 is 0.0116. 0.00116. Let me make sure again. Yes. Now, when I ask for between 65 and 80,000 miles, this is the part where you do both the z-scores. So that would be 65,000 minus 70,000 over 4,400. And then 80,000 minus 70,000 over 4,400. Now these two scores respectively are negative 1.14, because it's negative 5,000, so it's the opposite here, and then positive 2.27. So when we draw a picture, the area between them, here's negative 1.14 and here's 2.27. If I want the area between them, I take the area to the left of 2.27 and subtract the area to the left of negative 1.14. So if I go to 2.27, that's 0.9884 minus my score for negative 1.14, which is 0.1271, and I subtract them to get, it's like 0.8613. Now, part D is a more theoretical question. It says, suppose the company wants to warrant no more than 2% of tires. Where should it set the warranty? Now we have the area, and we need to take that 2% back to z-scores. So the tires that last the least long are the lowest 2%. Now what's the z-score that produces the lowest 2%? It's where the area to the right is 0.02. Now 0.02 looks like it occurs at about 2.05. So this z-score is negative 2.05. Now how do I go backwards from there? I use my same formula. That negative 2.05 is equal to whatever my tire value is minus 70,000 over 4,400. So how do I solve for x? I multiply the 4,400 over. So 2.05 times 4,400 times 4,400 is negative 9,020 equals x minus 70,000. Then I add 70,000. So we get that x is equal to, it looks like 60,980. So if it says I will pay the warranty for any tires that last less than, probably they'll go with 61,000 miles, because of 61,000 miles, maybe even 60,000 miles, just to be reasonable. That's probably where they're going to set the warranty. It's more of a theoretical question. You probably won't have this on yours. But the technical answer is 60,980. That means only 2% of the tires should last less than that long, so the only 2% they'll have to pay the warranty on. So this is Chapter 7 stuff, and we'll do Chapter 8 next.